Hi, this is CUSD Math 7 from Unit 5, Lesson 7, Adding and Subtracting to Solve Problems. Alright, so this is your homework packet here, and you may be doing. And again, as always, I usually don't do much of the first couple problems, because that's kind of a review of your lesson to see if you got it or not, but I'll talk through a couple things here. It says here is some record keeping from a coffee shop about their paper cups. The cups are delivered 2,000 at a time. So they get 2,000 new cups when they get a delivery. So they get an addition there to that. You want to look at the table here, and it says to explain what a positive and a negative number means in the situation. And when you look at the table, you see various days of the week, and you can see changes happening. We have a positive change here of positive 2,000. We have a negative number here, a negative, a positive, a negative, a negative, and then nothing happening here. This column, though, does seem to be talking about the change, and so we can assume this means a change in probably the number of cups that they have in their shop, because they're keeping track of the paper cups that are inside of their shop. So there's going to be a variance here of how many cups are in the shop as this goes along, and that's probably what these positive means it's probably going up, and negative means that probably the number of cups they have is going down. They're going to want you to look and see what's there at the end of the week. Okay, this is not what's there at the end of the week. This is the amount of change. That's a change number. It doesn't give you a number of cups they actually have. So keep that in mind there. This doesn't mean they have zero cups at the end of the week. There's been a change from where they started. And then a fun question here, a little bit more challenging, is how many cups do you think were used on Thursday, and explain how you know. And that's significant because without knowing that, you really can't get to this problem right here. As you can see, there's a big change right here. On Thursday, we have a positive 1,719 cups, right? So they increased the number of cups they had by a quite large number. And it's not like people came to the store and said, hey, can I donate a cup? We know that they get 2,000 cups delivered at a time. So that's significant because we know that if there was a delivery, they would have received 2,000. We would see a plus 2,000 like you saw right here. But we don't see just plus 2,000. We see plus 1,719, which means they must have also used some cups too in order to have a change of that only by the end of the day. So that's a little bit of a hint there. It's definitely a problem you're going to kind of work through and maybe struggle through a little bit. That's okay. Don't worry about whether you get it totally right or wrong. Just work on that and see what you come up with. Okay, moving down to number 4 and some more, because today's packet has a front and a back side. It says the table right here shows 4 transactions and the resulting account balance in a bank account. Fill in the missing numbers. Okay, so a transaction in a bank account is how much money you either put into your bank or you take out of your bank. The balance is talking about how much money you actually have in it once you've done the ins and outs. So a transaction can be positive, it can be negative, but the account balance is the total money that you have after you've done that. So for example, if we have $998.50 here and the transaction is a positive, which this one is, that means your balance is going to have that same amount. That's our starting point here. So you have to kind of look like a Z, right? So I start here, and then the next transaction is going to be right here, and it says, oh, we are going to take out, because it's a negative there, $156 from our balance. So what I'll do is I'll just make a little subtraction problem over here, and I have the $998 that I have in my balance, and I have a transaction where I'm spending $156.22. So then we'll just work out that problem. 10 minus 2 is 8. 4 minus 2 is 2. Keep your decimal where it needs to be. 8 minus 6 is 2. 9 minus 5 is 4. And 9 minus 1, is 8. So our new number here is going to be our new account balance. So we're going to put that right here and write $842.28. Okay, so that's how we're getting there. So this number then works to that spot. Now when you go here, now 842 minus or plus, so we're not sure, some number is going to get you to that number there. So you can think of it like this: 842.28, and we don't know, plus or minus something, is going to result in the new account balance of $659.42. Well, look at the difference between these two numbers. This number is much larger than this number, which means we're going to be taking something away. So we know for sure it's a subtraction problem. we're going to have some sort of transaction that's negative in nature, but we have to subtract in order to get there. So this is where you could think, if you wanted to try to fill in the numbers here, which we've done in the past, you could do that. You could think 8 minus what number will get you to 2, and you'd say, well, 8 minus 6. And then you get 2 minus what number gets you to 4. There's not a number that gets you to 4, so that's not going to work that way. You'd have to think, well, this must be a number bigger than 2, and I'm going to have to borrow from there to make that a 12. So it just starts getting too complicated there. The other thing you could do is you could just find the difference between these two, and the difference between those two will be this number right there. So let's try that real quick. If we do 842.28 minus our other total, right? So using account balance minus that account balance, that's going to show us the difference between those. So let's do that. 8 minus 2 is 6. That's our same 6. 2 minus 4 I can't do, so I'm going to borrow from here. 12 minus 4 is 8. Put a decimal there. 1 minus 11 I can't do, so I borrow. 11 minus 9 is 2. 3 minus 5 I can't do, so I borrow again. 13 minus 5 is 8. And 7 minus 6 is 1. So I know that my transaction amount is $182.86. Most importantly, though, I know that it is a negative amount, which we decided from this setup right there. We knew that it had to be negative, so this answer is going to be a negative 182.86. Okay, so that's what happens on that one here. For the last one, I'll let you do that one because we're going to start it here, and we can see what we're going to do. We're going to add the $44 to our account balance to get our new account balance. So you go ahead and do that one. Number 5. All right. We have a temperature at 7 a.m. at Mammoth Lake was 5 degrees below zero. 5 degrees below zero. So let's look at this. This is 0. We have 1, 2, 3, 4, 5. So let's say we start right here. That's our temperature at 7 a.m. By noon, the temperature rose 9 degrees. So if it rose, that means it's going to increase 9 degrees. Let's draw that out there. So here's 1, 2, from here, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to go to that point. So temperature is going to increase from -5 to this point, which is an increase of plus 9 degrees. And we can see that that means it's at 1, 2, 3, it's actually 4 degrees right there. Okay, that's great news. Then by 9 p.m. it dropped 7 degrees. So now from this point we want to go back the other way. A drop is going to be a decrease, 7 degrees. So we'll go 1, 2, 3, 4, 5, 6, 7 to this point here. Alright, and that's where we are. We are at -1, -2, -3. Okay, so this is a drop of 7. And we end up being right here at -3 at the end of everything. And it says write an equation for the situation and solve it. And use the number line to show. Well, we show that on the number line. So what have we done? We said our starting point was 5 degrees below 0. So we did -5. And then temperature rose 9 degrees, so an increase of 9. And then it dropped, so it decreased by 7 degrees. Okay. We could say that it dropped 7 degrees. We could write it as -7. We could also, it would be okay to write it as our next thing that happened is we added a -7. That would be okay as well because we're showing this is a decrease with a -7, but this is exactly the same thing. So when we solve that there, we end up being at a -3. All right. So that's how you look at that one. This is a very common type of problem dealing with temperature, and the other one you deal with a lot is elevation. We're talking about positive and negative numbers. Those are very common things that come up in relationship to those topics. All right, number 6. It says a submarine dives down 100 meters below sea level. So we're going down 100. It rises 25 meters, then descends, which means goes down 175 more. What is the new position relative to sea level? All right, so sea level's here. All right, so we began going down 100. Now they have all these little hash lines here, and we could just, we have to figure out what we want to measure this by. I went ahead and labeled mine as 25. I counted by 25, 25, 50, 75, 100, 125, 150, 175, 200, 225, 250, and 275. And then I just used my line and drew some arrows to show what happened. So it went 100 meters down, so we started here, and it went down 100 to that point right there. And then it rises 25, so then it went up to here. Got it. Then it descends 175 more. Alright, so this one I had to start here and think about, okay, we're going to go down 25, 50, 75, 100, 125, 150, 175 was right here. So that one I had to be a little more careful about how I was going to map that, since I wasn't actually on the number line. And I can look here and see where am I at. I'm at 250. Okay, so what does this mean for our new position? We would say that it is 250 meters below sea level. And that's how I would write this new position. Okay, so it's not a negative 250 because it actually has a distance. That's what I would say. You could measure this and you wouldn't have a tape measure that has a negative sign on it. It just means it's 250 meters below zero. Right? When you're doing the math part, you could think about it being negative, but just when talking about it, it's just at that distance. Okay, so let's turn the page and take a look at the back side. Alright, we begin first of all with a little cluster of problems here, and I'll just do a couple of them just to kind of get you in the mood. So let's find the sum, which is what happens when you add, or the difference, what happens when you subtract. Here we have two negative numbers that we're going to add together. So when our signs are the same, we find the sum and we keep the sign the same. So I'm going to do a 3.5 plus a 1.5. Add that up and we get 5.0. But because it's a negative plus a negative, it's still going to be a negative answer. So it's negative 5.0. Okay. Here we have a positive sign and a negative sign, and when the signs are different, we find the difference, and then we look for the number that has the greatest absolute value. In this case here, we look for kind of what we call the bigger number. And so in this case here, we're going to find the difference, but our sign should end up being negative. Here we have different signs, so we're going to find the difference, and we'll keep the sign of the larger number, or the larger absolute value, which is going to be negative. Okay, so that's little tips there, and you do those ones. Moving down to the next section, we have some fraction work here. So we have a fraction minus subtracting a negative number. Remember, always means to go ahead and just add, but then we're going to subtract a number again. Okay, and that's okay. So I'll let you figure that one out. Let's look at this real quick, because I thought this was a good problem. Maybe a little bit trickier to think about, but let's do a little quick number line. If I draw a number line and say I'm starting at negative 3.5, as on a number line, if this is 0 right here, I'd have negative 1, negative 2, negative 3, negative 4, and the half marks go in between like so. Okay, so we're starting right here at negative 3.5, and it says to add a half. Well, adding a half means we're going to go this direction on our number line, and we're increasing by simply a half. So I'm going from here to right here, because that's a half, which means that negative 3.5 plus a half is equal to simply negative 3. I just wanted to show you that on the number line, just so you can see how that works in case you were like, wait, I don't get how you got negative 3. It's good to sometimes see visually how that does make sense. Next section says, please rewrite each subtraction equation as an addition equation. So instead of saying p minus 12, we would say p plus a negative 12 equals 92. And do the same thing for these other ones here. Here we have subtracting a negative number, right? So if I had 5 minus a negative 4, that would become 5 plus 4. So do the same type of thing with what's there. And 15 is just like 13. Number 16 says, how much higher is 350 meters than 200 meters? So we're doing a comparison here to find the difference between these two amounts, right? You could think about it being, if we're talking about higher, and you have a tower, and you have this one is right here. Here's a point at 200 meters, and this point up here is at 350 meters. If it wants to know how much higher, we're talking about the difference in between. So what is this amount right there? If you had to go from 200 to 350, how far apart are those two numbers? I'm not going to add them. If I added them, I'd have 550, right? And that's not going to be it, because the distance there can't be 550. 550 is this plus this, which is somewhere way up there. That's not going to work. So it's not going to be an addition problem, so figure that one out. What is a change in elevation from 7,786 feet and 2,389 feet? Again, when you're talking about a change, we're talking about a difference here happening between this number and this number. Same idea. Okay, and all these differences, we talk about something you may have talked about in class, something called magnitude. Magnitude is that space between your altitude or change in elevation. The magnitude is always positive. Okay, so keep that in mind here. So this number is going to be positive, this will be positive. So to find this difference there, I do 7,786. I'm going to subtract 2,389. And let's go ahead and do that real quick. 16 minus 9 is 7. 7 minus 8 can't do, so I borrow. 17 minus 8 is 9. 6 minus 3 is 3. 7 minus 2 is 5. And so the difference there is 5,397 feet. That's kind of the space between these two elevations. All right, number 18. All right, this is some review from Unit 4, all right, which you did. Maybe you didn't quite do what the book said, maybe some little different, so let's see if we can help you out here. The store bought a pair of shoes for $50 and sold them for $80. So they bought them for $50, and we can see an increase in price to $80. What was the percentage of the markup? Now markup means, like we said, we're increasing the price to $80, right? It started at $50, but the store wants to make some money, so they don't sell it for $50, they sell it for $80. So that's going to be an increase of how much money? Okay, to find the increase of money, we would say, well, they sold it for $80, they bought it for $50, so they would make $30 is how much money they would make. So it's a $30 increase. When we're talking about what's the percentage of markup, you're wanting to find the percentage that 30 is of the original price. So it's really saying 30 is what percent of 50. So $30, the markup is what percent of 50. As a problem there, that means we're looking at really 30 out of 50 to decide if it's a percent, right? 30 out of 50 is how you say set it up as a percent. And that's going to be, if we reduce that down, we can reduce out the zeros, and we have 3 out of 5. And 3 out of 5, or 3 divided by 5, depending on if you have a calculator or not. If you don't, you could do it like this. You could do 3 divided by 5. And you could say 5 doesn't go into 3, but 5 goes into 30 6 times. 5 times 6 is 30. And we have no remainder, so we have 0.6 or 0.60. And as a decimal, it's 0.60. We want a percentage. So to convert a decimal to percentage, we're going to move to 2 spaces to the right to say 60%. So this is a 60% markup to go $30 more than the 50. Excuse me. All right, Priya orders a meal that costs $22. All right. If the tax rate is 8.5%, how much sales tax will be on her meal? We just want to find the sales tax only. We're not finding a total, just the sales tax. So to do that, if you recall, you need to convert your tax rate into a number you can multiply by 22. So this number here, 8.5%, to turn it into a number we'd multiply by 22 times 22, we're going to move the decimal 2 places to the left, put a placeholder 0 there, and so we do 0.085 times 22, and that's going to give you the actual tax amount. Okay, and so I'll let you fill that in. I'll give you some hints there. It should be that much. All right, if you get something bigger than a 1-digit dollar amount and 2 digits for there, you did something a little bit off there. All right, finally, Priya wants to leave a tip for the server. Okay, so tip is server. How much do you think she should pay in all if she wants to tip 20%? Okay, so in all is a great question because it's a continuation of this one here. In all means you're going to have the $22 for the meal plus whatever that amount was for the tax plus however much you want to give as a tip. And that'll be your in all. So you're going to figure out your tip amount. Well, the tip amount is 20%. So if we found 20% of 22, again 20% as a percentage is here, as a decimal becomes, move it over here to 0.2, right? That's our 20%. Decimal becomes 0.2. 2 times 2 is 4. 2 times 2 is 4. We have 1 behind the decimal, so we have 4.4. So our tip amount is going to be 440. So when you find your tax, we'll put the tax there. We'll add it to the total, the bill plus the tip and the tax, and that's going to give you your answer right there. Okay, so enough little hints in there to let you figure that out, and that's it for today. Have a great day, and we'll see you next time.